Currently right now, what we have is, I know there's nobody really watching this, but what we'll do is hopefully people can go back online if they'd like to and be able to review for it. So what we're going to do is just simply go through some problems. And if you have a question, 770-757-2240. So we're going to do that in just a second. Let's get started. Homework problems, make sure with the ones that the word problems I know are not going to be on there. There'll be one word problem. That one word problem will be a basic one, very similar to what would be on the notes. But just so you kind of have an idea of that, I just wanted to give you hopefully a heads up on it going forward off that as well. What we're going to do is kind of as we get started here, if you have any questions, again, I'm going to try to address the most that I possibly can here. And then afterwards, we'll kind of wrap it up and then go from there. All right, let's get it started. Let's start that screen share. We're going to go straight to number one. We're going to hit each one, maybe not every problem, but we'll hopefully hit most of them, or at least one type of each. Okay, let's look at number 53. 53 says the given angles in standard position determine the quadrant in which the angle lies. Well, in numbers 1 and 2, the important thing to note, where is the quadrants there? So if I had my X and Y axis, I know my quadrant 1 is top right, then 2, then 3, then 4. Okay, so as I go through, I know that 53 degrees is through here. Therefore, we know it's in quadrant 1. Remember, the negative 60 would be going in the opposite direction, going in the negative direction. We know it's not quite to 90 degrees, but it's right in between. So therefore, we know this quadrant, this one, which is number 2, would be in quadrant 4. Okay, so we've got our first two problems there. Let's check out our next one. The next one states, find the radian measure of the central angle of a circle of radius r that intercepts an arc of length s. So if I said, all right, here's my intercepted arc, and again, if I had a picture here, okay, I've got this. This is my s, my intercepted arc, where this is my theta, and my r would be my radius. So my intercepted arc equals my radius times my theta. So it says here that r is 2/3, and s, which is my intercepted arc, would end up being 16 feet. The question is what is theta? Well, actually, I can actually multiply by 3/2 on both sides, and 2 goes into 16 8 times. So when I do that now, I get 24 radians is what is equal to theta. Okay, so 24 radians equals theta. So we know that that is number 3. Let's look at the next one. The next one refers to number 4. Convert the angle in degrees to radians. Anytime, remember, I have negative 134 or 135. Anytime I go from degrees to radians, we always want to put what we're going to up on top. So we're going to put that pi up on top with the 180 on the bottom. If I was converting 2 pi over 3 to degrees, I would simply multiply by 180 over pi and then reduce and then go from there. So if I were to simplify here and divide by 5 on both sides, I'd end up getting negative 27 pi all over. Divide by 5 here, I'd get 36. Now, is there anything else that goes into this evenly? The answer is yes, because if I divide by 3, my answer would then be negative 9 pi over 12. Can I go any further? Yeah, if I divide by 3 again, I get negative 3 pi over 4. So my answer, negative 135, is the same thing as negative 3 pi over 4. And remember, it does say keep it in terms of pi. Now, number 5 is one where we're converting degrees to radians, except this time we're taking negative 157 and we're converting it by multiplying by pi over 180. But notice the directions. The directions specifically state that you have to convert it and then change it to a decimal. So if I were to, figure this out here, what I would do is go to my calculator and I'd say, all right, negative 157 multiplied by pi. Okay, get that answer. And then I'm going to divide by 180. Since I'm getting it to the nearest tenth, I notice that my radians is going to end up being negative 2.74 radians. Negative 2.74 radians. All right. Hope that's helpful for you so far. Again, we've walked through quite a few. Let's go to the next one. This one, again, moving forward. We won't hit everyone, but hopefully give you an idea of what is and what is not on that quiz here, or on the test here. On number 6, 6 is a very, very good one because it converts radians to degrees. All I'll tell you is if I have negative 41 pi over 18, I can multiply by what I want to get up on top. So since I'm going to degrees, I put the degrees on top and the pi on the bottom. Think about it this way. The pi's have to always cancel. So then I go 18 goes into 180 10 times. 10 times negative 41 would be negative 410 degrees. Okay, again, these are just little ones, but they'll make a big difference when going to the test. All right, next one is negative 120. It says sketch it in standard position. Well, if I start at my original spot over on the outside on the axis, I know I could go negative 90 this way. So if I go negative 90 and then I combine another negative 30, okay, another negative 30 will continue here, and this will be negative 120 degrees, negative 120 degrees. So again, that's negative 30, the standard position, but then remember it'll go into quadrant 3, okay? All right. Man, we're already rolling. We're on number 7 and continuing forward. All right, number 8. All right, number 8 is one. It starts getting a little bit trickier. It says find a positive angle less than 360 or 2 pi. So since one of these, and I'll kind of do one of them because 668, you'd subtract 360 and go from there and yada, yada, okay? That one's number 9. But on 18 pi over 5, instead of subtracting 360 or doing whatever I need to get from 0 to 2 pi in between, what I can do is subtract 2 pi. So if I subtract 2 pi, I can multiply the bottom by 5 as well as the top by 5. So if I do that now, multiply top and bottom by 5, I'll end up subtracting, getting me 8 pi over 5 as my answer, okay, as my answer there. So what is my coterminal angle? Again, I rotated 360. I can go in the positive or negative direction depending on what I'm trying to get there. But I noticed that, again, when I did that, I got 8 pi over 5, which falls in between 0 and 2 pi, or 0 and 360. All right, number 10, don't worry about. Number 11, notice that when a point is there, anytime I have a point, and I know I'm going quick through this, but anytime I have a point like 3/8 or square root of 11 over 4, or square root of 11 over 8, we'll say, remember the sign is always related to my y, in this case square root of 11 over 8, and my cosine always relates with my x, which would be 3/8, okay? So we have all of this stuff that we've gone through, and now all of a sudden they throw a little bit of a curveball. But just wait, throw it to left field, all right? Negative square root of 55 over 8, comma, negative 3/8, okay? The question says find what cotangent of t is. Now cotangent, remember, is not x over y, or I'm sorry, not y over x, because remember tangent is y over x, but this case, because it's the reciprocal, it's really x over y. So because we know it's opposite, when we plug in x, our x would be negative square root of 55 over 8, all over negative 3/8. So I take the bottom and multiply, or take the reciprocal to the top to get negative square root of 55 over 8 multiplied by negative 8 over 3. The 8s will cancel like a cancel party, leaving me with negative square root of 55 over 3. Okay? All right. Let's see who all is watching right now. I've got 0 viewers still. Man, I'm all by myself. Maybe I should sing this song. All by myself. Don't want to be all by myself. All right. You like that harmony? All right. I hope so. Number 13 says use a unit circle to find the value of the trigonometric function. Remember, at 2 pi over 3, we've got to think, all right, if tangent is 2 pi over 3, and that's what we're looking for, where's 2 pi over 3 on a unit circle? Well, I know that if I was thinking, it'd be kind of over this away. And in noticing that, what I could do is think, oh, yeah, I remember that. That's 120 degrees. Well, at 120 degrees, I have negative 1/2 comma square root of 3 over 2 as my point. So if I had y over x here, y would be square root of 3 over 2, because that's my y of my point, and my x would be negative 1/2. Also note that you do not have to write the unit circle for the test. I will give that to you. Okay, I will give that to you. So flip the bottom to the top. We'll start from the bottom, we'll be there. So we have square root of 3 over 2 times negative 2 over 1. Cancel, cancel, leaving me with negative square root of 3. All right, perfect. All right, notice on number 14, 14 is definitely not on the unit circle. 15 is. That should be fairly easy. We did one very similar to that. And let's do number 16. So let's do 14 and 16. On number 14, it says, what is sine of 9 pi over 4? Well, remember that 9 pi over 4 is something that is not on the unit circle. But we do know that it's a little bit greater than 2 pi, because 4 goes into 9, 2 and some change. So what we could do is just take 9 pi over 4 and find a coterminal angle to it by subtracting 2 pi. So if I put a 4 on the bottom to get common denominators, I have to multiply by the top to get 8. And when subtracted, I get now pi over 4. So we're not quite done, but what is sine of pi over 4? Well, when looking at a unit circle, my point at pi over 4 is square root of 2 over 2, comma square root of 2 over 2. Okay, that's that point. So my sine, which is the y, would be square root of 2 over 2. All right. 16 states, what is the cosecant of negative 5 pi over 4? Well, because it's negative 5 pi over 4, we know that 5 pi over 4 would be over in this direction, but because it is negative, what we can assume is that all of a sudden it's going in the opposite direction, to where now this blue one would be negative 5 pi over 4. We know that once I do that, I know that the kind of reference angle here would be pi over 4. So when setting this up, my question is what is cosecant of pi over 4? Again, note, at pi over 4 of this way, and it's actually not pi over 4, it's actually going to be 3 pi over 4 if I was going in the positive direction here. At 3 pi over 4, I know my points are square root of 2 over 2, comma, square root of 2 over 2 with the x being negative. So cosecant is related with sine. So I take the reciprocal of this to get then 2 over square root of 2 as my answer. I'll multiply the top and bottom by square root of 2 to then get me 2 square roots of 2 over 2 divided out. My answer would just be square root of 2. All right, so hopefully you're tracking on that. Hopefully you're doing that appropriately and doing it the right way. All right, next one. All right, 17. What is secant of t? Well, if you know cosine, remember cosine is, a secant is the reciprocal of cosine and vice versa. Okay, so that's important. But that's 17, should be fairly easy. On number 18, this is a very good one. Okay, very good one. You really need to know this because I went through it briefly, but I didn't go through it as much as I probably should have off the units here. It states that sine of t is equal to 8 over 9. Well, since I know this Pythagorean identity, which again you can have in class, what I'll do then is put 8 over 9 in for sine. So when I do that, I'll get 8 over 9 squared plus cosine squared t equals 1. So 8 over 9 squared is 64 over 81 plus cosine squared t equals 1. So doing that now, I subtract 64 over 81. Then I'll end up taking the square root of it, but we're coming to that. To get common denominators, I put 81 over 81. And when I subtract it, I should get 17 over 81 there. So now I've got over on the side, cosine squared t equals 17 over 81. I'm going to square root both sides, My answer now is cosine of t is equal to square root of 17 over square root on the bottom would be 9. So that should be what my cosine t is there moving forward. Okay? All right. All right, kind of taking a deep breath here. Did number 18. Number 19 is another one that you could kind of solve for. I'll only have one of those on the test, but that's a good one there. Also, number 20, the answer should be 1. You might say, why? Why is that, Coach? Well, again, if I have tangent of 1.8 and I put it over 1 and I multiply by cotangent of 1.8, we know cotangent of 1.8 is just the reciprocal of tangent. So I could just say tangent of 1.8 times 1 over tangent of 1.8. So these cancel. My answer would then simply be 1. All right. Next one, cosine 2 pi. Kind of put it over here on this side. In fact, let's do this. Let's go over here. Let's go there. All right, that's going to be good. Do something a little bit different. I like that. Sweet. Okay. Now the next one, cosine of 2 pi over 3, it says use a calculator. But you know that if it's supposed to be in radian form, you got to change your calculator to where it now is in radians. So I'm going to do this one just to make sure we're tracking. So cosine of 2 pi over 3, we're going to put this in a calculator to get out a decimal that round to the 2 decimal places, okay? 2 decimals. So what you could do now, get your graphic calculator out, check that mode, make sure that that mode is in radians, okay? And then I'll just say, all right, what is the cosine of parentheses 2 pi divided by 3? All right, check that. The answer, at least what I got, was negative 0.5 radians. Okay, negative 0.5 radians there. Okay, so that's what we were looking for on that. That's exactly what we're looking at going there. Okay, if you're thinking about that, you think, well, what's negative 0.5? Well, think about it in terms of the unit circle. If you went to 2 pi over 3, you should get negative 1/2, or in this case, negative 0.5. Okay? All right. And I'm going to get back out my review here. Sweet. Start rolling through this stuff a little bit faster. Number 21 we did. Number 22. 22 is a good one. That one states, all right, we've got this right here. We got 2, I think 2 here, 3 here, and here's theta. The question becomes, what is the secant of theta? Okay, remember secant is hypotenuse over adjacent. It correlates to cosine of theta. In fact, it's its reciprocal, okay? So now I don't have my hypotenuse. That's my problem. Now, if you know 2, 3, 5 triangles are there, then you could do that. But what another way you could do it is just 2 squared is 4 plus 3 squared is 9. And I actually didn't mean that. It should be 3, 4, 5, not 2, 3, 4, 2, 3, 5. So it's actually going to be incorrect. But I'll take 2 and square it plus 3 squared, which is 9. And I'll end up getting 4 plus 9 equals x squared. We'll put that as x. So if I were to combine it together, I'd get 13 equals x squared. When I square root both sides, I know my x is going to be equal to square root of 13. Okay, and it can't be negative, remember, because of the fact that a hypotenuse is never negative in that situation. So if this is square root of 13, the hypotenuse for my secant theta would be square root of 13 over, and remember the adjacent is right next to the theta. It could be down here, it could be right here, and same is true for the opposite. But we know that that will be a number 2. Okay? All right. Number 24. 24, if I were to look at tangent of 60 degrees, you should get square root of 3 over 1. That's fairly easy. But the next one is a little bit tricky because you see that it's one that we normally wouldn't go through. We wouldn't go through this one. Or I haven't gone through this one. This one states, what's the tangent of pi over 6 minus secant, or sine? Sine rather, not secant. Sine of pi over 3. Now, look at your unit circle. At pi over 6, this is going to be square root of 3 over 2, comma 1/2. Whereas at pi over 3, sine of pi over 3 that is, I will end up having a point that is 1/2, comma square root of 3 over 2, and both would be positive. Well, with tangent, we're going to do y over x, where sine is simply y. So when I do y over x, I get 1/2 over square root of 3 over 2 minus, and what's the y on this side? Be square root of 3 over 2. And I'm going to flip this and multiply by the top. So I'll have 1/2 multiplied by 2 over square roots of 3. 2's are going to cancel now. Little cancel party, and I'll get 1 over square roots of 3 minus square root of 3 over 2. Since it doesn't have a common denominator, if I multiply this side by 2, okay, on the top and the bottom, as well as this side by square root of 3 on top and bottom, I'll end up getting 2 minus 3, because square root of 3 times square root of 3 is 3, all over 2 square roots of 3. Multiply by square root of 3 on top and bottom, multiply it there, and now what I'll end up getting is 2 root 3 minus 3 root 3 all over 2 times square root of 9, or we'll say 2 times 3, which would be 6. Okay? And what we'll do is we'll actually leave it just as is, because that 2, 3, and 6, nothing can divide into it evenly. All right. Sweet. 26, 27. If you need some help on word problems, come by the room, either like on Friday morning or even tomorrow morning. Remember that tomorrow that we are, I'm sorry, on Friday, make sure you know, again, test days that day. We'll get right straight into it. So you need to be sure to be ready right away. Okay? All right. Last one, 28. Oh, negative, or number 28 here. We have A here, 29 degrees, 19. Now, how do I find A? Well, I know that the A is going to be my opposite side, 19 is adjacent side, and 29 is my theta. So what I could say is tangent of 29 degrees equals opposite over adjacent. So tangent of 29 equals, my opposite is A, and my adjacent's 19. So if I were to multiply by 19 on both sides, I could take 19 tangent of 29, set myself up pretty good. So here we go, 19 tan 29. I get 16.86. Now, what's the problem with that? Well, let's check my mode real quick, because I noticed that, oh, my mode's back on radians. So guess what? I've got to do it again. So let's put it back into radians here, and notice that my answer would actually be 10.53. Notice the difference. This is degree mode, or this one would be radian mode, which would not be the correct answer. So 10.43, not radians, but 10.43 units is what A would end up being. Okay. Again, I hope this was helpful for you. This is not to be the only thing that you do to study, but I know that it might be a huge help for you going forward. Again, hope you have a great and fantastic night, and I will definitely touch base with you soon. See you, Spartans. Have a great night. Bye now.